All right, since we have already gone over how to create a truth table for negation, conjunction, disjunction, and also for conditional and biconditional statements, now we can go over creating a truth table that incorporates a little bit of everything. So we're going to look at this example, which starts with an actual sentence. So let me go ahead and read it. It says, if today is not Sunday, then I have homework and I need to get a laptop. So again, this sentence is composed of meaning statements. So we have a statement which says today is Sunday. We have a statement that says I have homework, and we have a statement that says I need to get a laptop. So we're going to have to translate this sentence using the little baby statements, right? So first one here is today is not Sunday. So this one looks like P, but of course the word not we should know is negation. So this right here can be represented by negation P. I have homework. So that's actually Q right there. So I'm going to go ahead and put Q. I need to get a laptop. So that right there is R. Okay, so I started with my letters P, Q, R. The only one that had a negation was P. Now there's also little hidden words in there we have to look at, right? So the word and, hopefully you picked it up. Remember, and is conjunction. And then we have this new one here, right? If, then. So if then means that if negation P, then that's the place where we put our conditional statement. Okay, so just remember from now on, every time you see if then, that means conditional. In this particular example, we're not going to have a biconditional, but just so you know, biconditional would have in a sentence sounds like if and only if. But since we have just an if and then, we just put a conditional, which is the one arrow from the left to the right. Now, I know you're like, what in the world happened with those parentheses? So remember, parentheses come into play when you have a comma. So since we have a comma, there's going to be parentheses. Now you have to ask yourself, to what side of the comma is there more statements? Since there's more statements to the right of the comma, because we have a Q and an R, then that's where the parentheses go. If we would have had more statements to the left of the comma, then we would have grouped those together with parentheses. But in this case, we only have a not P to the left. So that one's just by itself. Since we have a Q and an R to the right, those are the ones that we group in parentheses. So again, this is the first step. Now that we have this, now we can actually start creating our truth table. All right, so here we go. Again, we have 3 letters. So we should start with a total of 8 different rows. And again, these are always going to be the same, just like we talked about it in a previous video. The first column is always composed of 4 truths, 4 falses. The second column is composed of 2 truths, 2 false, 2 truths, 2 false. And the third column is composed of true, false, alternating all the way down. So true, false, true, false, true, false, true, false. Right, so that's always the easy part, is just setting up the first column. So we have 3 letters. We're going to have P, Q, R. We're going to have 8 rows. If for some reason this problem only had 2 letters, P and Q, then our table would be a little shorter and it would only have 4 rows. So something to keep in mind. Now, once we have this, we could create a truth table. Again, you ask yourself, do we have negations? Do we have little statements in there? We do. We have a negation. So let's just start with that one, right? So we create a column for negation P. In order to fill this up, remember, negation P is the opposite of P. So I come over here and all I do is find the opposites of all of these. So all the truths, if you notice, became falses, and all the falses became truths. So pretty simple. So let's go back over here. I already have a column for this. Now, remember, I cannot tackle this yet because there's stuff over here that I don't have columns for yet. So let's ask ourselves, do we have a column for Q? Yes, we do. Do we have a column for R? We do. So now I can actually tackle this inside the parentheses. That's going to be my next column. So my next column is Q and R. So remember, for conjunction, they both have to be true. So you're not looking at the whole table. We're just looking at Q and we're just looking at R. So let me go ahead and make those here. So we're looking at Q and we're looking at R, and we're combining them with a conjunction. And again, conjunction, they both have to be true to get a truth statement. So here we have true and true, which should actually be true. Sorry about that. So that should be true. True and false gives me false. False and true gives me false. False and false gives me false. True and true, which is true. True and false gives me false. False and true gives me false. And then false and false gives me false. So again, this is a big statement, but we did have to know our original truth table. So it all depends if you know what a conjunction means, if you know what a negation means. Okay, so let me go ahead and erase this. But let me just make sure I don't erase this one, right? But this one we had said it was true. So let me just fix that real quick. All right, so look at that. We already have a column for this right here. We already have a column for this right here. So now we can actually tackle the whole statement. So we're going to have to make an extra column for this one. So let me again pretend that is not there. This should be true. And if you notice, now we have a column for the whole statement. So what we're going to do now is look at the column for not P, which is right here. And we're going to look at the column for Q and R, which is right here. And we're going to join them with a conditional statement. So I'm going to have to join these two with a conditional. And in case you forgot, remember that you have to depend on your original truth tables. Conditionals are always true, except when we have a true. If true, then false. So before you make your truth table, ask yourself, do I remember what a conditional means? So this is the only one that's going to result in a false. All right, so with that being said, let's go ahead and get started. If false, then true is true. If false, then false, true. If false, then false, true. If false, then false, well, obviously true. All right, if true, then true, true. If true, then false. That one should make your head ring and be like, oh, that's the one that is always going to be false. So that should be false. If true, then false. That one's also false. If true, then false. That's also false. So again, we had to rely on our previous knowledge of when is a conditional true, when is a conditional false. But after that, we made it. That's it. That would be the complete truth table for this statement.